we believe as an industry that in the next 1 year, the vast majority of programmers will be replaced by AI programmers. So that's 1 year, okay? What happens in 2 years? Well, I've just told you about reasoning, and I've told you about programming, and I've told you about math. Programming plus math are the basis of sort of our whole digital world. So the evidence and the claims from the research groups in OpenAI and Anthropic and so forth is that they're now somewhere around 10 or 20% of the code that they're developing in their research programs is being generated by the computer. That's called recursive self-improvement, is the technical term. So what happens when this thing starts to scale? Well, a lot.
So far, 2025 is shaping up to be a monumental year for AI. And according to top AI researchers, 2026 is going to be the year in which millions of jobs will be replaced by AI. In this interview with Eric Schmidt, former CEO of Google, he gave some pretty eye-opening statements that we can't ignore. Watch this.
So AI is your thing. The topic today, however, the convergence of AI with biotechnology. I'm wondering, this report is intended to increase awareness of biotechnology and AI, to increase knowledge, to get people excited about it, maybe even to get people to enter the field. If you had to give one example of this convergence of AI and biotechnology that you think might do that, have you got one?
Well, first, let me thank Senator Young, the other members of Congress, Caitlin, obviously, who's here, and the whole team that put this report together. I'm really proud of the work that we did. The commission spent an awful lot of time on the details, and I learned, when you do these things, you learn a lot, as well as get to contribute. One of the things that I learned that I wanted to make sure I emphasize, it's in the report, is that I had assumed that the biotech people had figured out scaling. And after all, these are huge markets. Right? I live in a world of scaling. But in fact, there's a huge valley of death. And I would encourage you all, to the degree that you're in this business, really think about it. Our recommendations in the report are fundamentally around the science of scaling. Technically, that means how many vats, how do you grow them, that kind of stuff. Very highly technical bio issues. There's also a recommendation in here around building an infrastructure for scaling. So what's happening is you have these incredible startups full of these incredibly people, and they raise enough money, they do something really interesting, and they're in between. They're not useful enough to scale, but they're useful enough to have succeeded and not be able to get the money because the economics don't work. This is a well-established problem, and I would encourage you, if there's one thing that you want to take away from the report, there's a lot of things which I'm sure everybody in this audience understands, the underlying science, the ability for AI to accelerate both drug discovery, but also its misuse. I was very involved with the misuse issues. There's lots of evidence that the new models, if they're unconstrained, can produce bad pathogens, in particular viruses. Just take an existing virus and modify it a bit, and off we go. One of the way to understand, and the reason, and I want to thank SCSP, the entire team, Illy and his whole team, obviously Eugenie. The reason we put all this on together is that this is a big deal for America. This is a multi-trillion-dollar industry. There's lots of evidence that China is putting enormous amounts of money into dominating this space. They have lots of technology, they have lots of stuff they stole, all the usual arguments, and we document all that in the report.
In the next part of the interview, Dr. Eric Schmidt calls AI a ticking time bomb, and he presents a pretty interesting logic behind this statement. Watch this.
I'm the primary funder of a particular group that has built a model. It first learned how to do chemistry, and it was trained as a foundation model for chemistry, and it's attached to a robotic lab. And what this model does is it generates hypotheses for drugs of one kind or another, and it just generates them. God knows if they're right. And then overnight, the robotic lab tests them and gives a report overnight, and then it starts again. And the reason I'm mentioning this is the future model of the fusion of AI and bio, right? The AI system generates all sorts of candidates to reduce the, essentially the search space. If you think about it algorithmically, it's an exponential with too many degrees of exponential. So you have to come up with some way of reducing the space. So this particular group is using AI to reduce the space, run the things, and so forth. Their objective, we'll see if they pull it off, this is a research project, is to identify all human druggable targets within the next 2 years. If that occurs, then that information goes straight into the drug industry. Now, it's a different way of thinking, and it's profound in that it gives them the targets they need to go build drugs against. That's interesting to me. It's the combination of AI and a robotic lab that does something in a wet lab, essentially. So one model that you should think about is wet labs will be roboticized, and the wet labs will have they're not humanoid robots, they're arm robots, and they go boom, 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 and they do the pipetting and so forth and so on, and they do it 24 hours a day. That's a major change in the way the biotech industry works.
So if there was a spectrum of the degree of cooperation and collaboration between AI and biotech, 1 being the lowest, 10 being the highest, where are we now on that spectrum?
It depends. I'm going to give you a non-politically correct answer. It depends on your age. If you are a graduate student in this area, every single PhD project now uses some form of AI in the way that I described. So speaking as the AI person in the room, we won, right? We got complete proliferation. By the way, that's also true in chemistry, it's also true in physics, it's also true in material science. So and you and I have talked about this, my overall view is that AI is underhyped, not overhyped.
What do you mean?
Well, let me come back to that. But the key thing to understand is that the seed corn of research, right, which is how we work as a nation, is founded by graduate students and postdocs, and they're all using this technology. Most of the applications I have no ability to understand, but I do see the tools in use.
So, underhyped. It seems to me I read about AI every day.
Well, if you actually read the press, it's every nanosecond because what happens is every company is now an AI company, even if they don't do AI at all, because they figure that it increases their valuations, which is useful in today's market. Sorry.
Very.
So I think that one way to express the idea is in this room, everybody understands the ChatGPT moment. Everyone here has used ChatGPT, now 4.0 with a new one coming. Gemini, there's a new one called 2.5, which is beating the other ones. I'm pleased for that as a big Google person. Claude 3 is the best one for programming, and they're all in the same equivalence class. The Chinese model, DeepSeek, is also in the same equivalence class. Grok 3, which has just come out of the Memphis data center with Elon, which is now part of the union of Twitter and XAI, is also in the same class. You think of those as language to language. Ask it a question. I was talking to somebody who was explaining to me that they use it for relationship advice, and another person told me that he used it for psychological advice. And I said, do you realize that it wasn't trained to be either a relationship coach or a psychiatrist? And in fact, it's probably illegal to say that you're a psychiatrist, because trust me, it didn't pass any of the tests and it hasn't been vetted. Well, nobody cares. The power of these models is extraordinary. And whenever I have a complicated question, I just ask one of those services. And they have differences, but they're roughly in the same category. That's last year's story that everybody thinks is the current story. The next story is the ability to do planning. Take a look at OpenAI R3, O3 or DeepSeek R3, and you'll see that they do this incredible demo. You ask it to show it what it's doing, or do deep research, which is available in most of these things. And it'll show you how it goes up the decision path. It'll try something, it didn't work. It goes back, it tries something else, didn't work. Oh, goes here, oh, it worked, and then it goes over here, and so forth. It's following the tree of choices. Now, what's interesting about that So you sit there and go, why is he so emphasized that? By the way, that's how we think. Right, let's pause. We went from language conversation, and furthermore, the foundation models today in biology use sequence prediction to predict biological elements, chemistry, so forth and so on. That's all well established. But the big breakthrough now through a technology called reinforcement learning is this. So you go, okay, well, that's pretty impressive. Okay, so we believe as an industry that in the next 1 year, the vast majority of programmers will be replaced by AI programmers. We also believe that within 1 year, you will have graduate level mathematicians that are at the tippy top of graduate math programs. There's lots of reasons to think this is going to happen. This is the consensus. You go, okay, well, that's pretty interesting. Now, I can't do that kind of math. Very few people can do that math. How can the computer do that math better than anybody else? To some degree, it's because math has a simpler language than human language. So the way these algorithms actually work is they're doing essentially word prediction. So you take a sentence, you take a word out, and then it learns how to put the correct word back in. This is called the loss function. And it's optimized to do that at a scale that's unimaginable to us as humans. So you do the same thing for math. But there you use a conjecture and then a proof format through a protocol called lean. In programming, it's pretty simple. You just keep writing code until you pass the programming test. So strangely, the first question I always ask programmers is, what language do you program in? And the correct answer is it doesn't matter. Because you're trying to design for an outcome, you don't care what code is generated by the computer. This is a whole new world, okay? So that's 1 year, okay? What happens in 2 years? Well, I've just told you about reasoning, and I've told you about programming, and I've told you about math. Programming plus math are the basis of sort of our whole digital world. So the evidence and the claims from the research groups in OpenAI and Anthropic and so forth is that they're now somewhere around 10 or 20% of the code that they're developing in their research programs is being generated by the computer. That's called recursive self-improvement, is the technical term. So what happens when this thing starts to scale? Well, a lot.
Now, in this part of the interview, Eric Schmidt makes a prediction on when AGI will arrive. He expects AGI to happen within 3 to 5 years. And to be honest, this timeline is not good news for humans because AGI is expected to replace more than 90% of the human workforce.
One way to say this is that within 3 to 5 years, we'll have what is called general intelligence, AGI, which can be defined as a system that is as smart as the smartest mathematician, physicist, artist, writer, thinker, politician, maybe not in the same level, but you get the idea. Just the creative industries and so forth, but imagine that in one computer. Okay, well, that's pretty interesting. I call this, by the way, the San Francisco consensus, because everyone who believes this is in San Francisco. It may be the water. What happens when every single one of us has the equivalent of the smartest human on every problem in our pocket? So it means you have the best architect when you have an architecture problem. Another thing that's going on is the development of agentic solutions. And agents are referred to systems that have input and output in memory, and they learn. An example here is that I want to buy another house. I happen to like Virginia. I grew up in Virginia. I say, find me a house in the greater McLean area. Look at that's one agent. Look at all the rules, figure out how big a house I can build. That's another agent. Do the transaction to buy the land. That's another agent. Design the house with a human architect, right? But sort of ignore them for most of the thing, but they have to sign it off. And then I approve it, and then find the contractor, right? Hire the contractor, pay the bills, and then at the end, sue the contractor for lack of performance. Okay? Now, I just gave you the stupidest possible explanation. I just described every business process, every government process, and every sort of academic process in our nation.
So it isn't just the programmers that are going to be out of work. We're all going to be out of work.
No, that's not a consequence. I'll come to that. But the reason I want to make the point here is that in the next year or two, this foundation is being locked in, and we're not going to stop it. It gets much more interesting after that. Because remember, the computers are now doing self-improvement. They're learning how to plan, and they don't have to listen to us anymore. We call that superintelligence, or ASI, artificial superintelligence. And this is the theory that there will be computers that are smarter than the sum of humans. Yeah. The San Francisco consensus is this occurs within 6 years, just based on scaling. Now, in order to pull this off, you have to have an enormous amount of power. I was here yesterday testifying about this, and we need, I can talk at some length about how many gigawatts and how many nuclear power plants and all that kind of stuff we can talk about separately. This path is not understood in our society. There's no language for what happens with the arrival of this. I wrote a book on this with Henry Kissinger called Genesis, which I recommend, obviously, because I wrote it. Available in your usual places. But the important point is, this is happening faster than our society, our democracy, our laws will address. And there's lots of implications. That's why it's underhyped. People do not understand what happens when you have intelligence at this level, which is largely free. That's the point.
How do we get ready for it?
Well, we start by talking about it. And by the way, on the jobs thing, everyone assumes that automation will eliminate jobs. If you look at the history of automation ever since the looms and in 300 years ago, the jobs are changed, but more jobs are created than destroyed. In this case, you'd have to convince me that this time is different. If you look in Asia, where they, for whatever reason, are choosing not to have children, the Asian reproduction rate is in the order of 1.0 or lower. So they're rapidly disappearing. So the Asian countries are very, very quickly automating. The tools that I'm describing will allow the few humans that will be working very hard in 30 or 40 years, if these trends continue, the rest of us will be dependent on those hardworking humans. It'll make their productivity much greater.
We aren't the only ones working on this. Talk about the state of the competition, if you would.
Well, first place, the American model is the big companies that you all know. Meta just released a version of Llama, it's called Llama 4, which is also in the ballpark, and they play a slightly different role. They've done a very good job because they release it in what is called open weights. That is, they actually show how the algorithm works. The other guys are completely proprietary. These are complicated business decisions that everybody's making. In China, the DeepSeek moment is equivalent to our ChatGPT moment. I was there with Henry, and this is what happens when you're talking to the Chinese about AI with Henry. And this means we are alive and we're listening to you. Thank you very much. Right? That's not what they're doing anymore. When DeepSeek showed up and our stock market lost $1 trillion in one day, all of a sudden they began to understand the scale of what it was. So now there is a massive program in China to accelerate these things. I had thought, Illy and I and some of the other people in this room worked really hard on these chip controls. And the chip controls have been, in my view, largely effective. How did China get around them? Well, some of it was straightforward theft and evasion of the tariffs, but they're sufficiently smart. They created new algorithms that used different kinds of computing to move forward. Because China operates in open source, that is, they release the software to everyone, there are two things that happen. We Americans immediately saw their idea and incorporated it in our own. So thank you very much, China. You invented something new. We immediately incorporated it. But second, because it's free, the proliferation issues around Chinese models have now become a very big deal. And our government is trying to figure out, without success so far, how to handle this question. It's a very tricky question. We call these wicked hard problems.
So we need smart people to be doing all this engineering. I want to ask you about some current events. We have seen in recent weeks the suspension of research programs at some of the premier U.S. universities. There have been layoffs and cuts at some of the government's premier scientific organizations. Some international students are choosing not to come to the United States. Others are leaving because they're afraid of being swept up on the streets. And some top US scientists are looking for jobs elsewhere, and they're being courted by other governments. do we risk losing the brain power that we need to stay competitive both in AI, in biotechnology, and every other emerging technology?
I had thought that this was just the usual government stupidity around politics, but here are some of the facts. Last week I was in London talking to people, and they said that we are preparing for people who are moving back from the US because they don't want to work in this environment. They figure they're going to get here. These are British people, right, like our best allies. The damage of the 15%, everybody understands here, there's this thing called the indirect rate. And the current government makes the claim that the universities are overbilling against the 15%, which is false. It turns out that the way the structure was erected in the 50s, this is under Vannevar Bush, was that the people were in the direct costs and the labs were in the indirect cost. Right. So if you fully burden the cost, the overhead rate is somewhere between 10 and 15%. This is evidenced, for example, by the Gates Foundation, and I'm a philanthropist, so I know these things, but they look at total cost. The government has chosen to use this as a mechanism falsely to attack science. If the government has a problem with specific scientists or specific science research, please have a good time. But this looks like a total attack on all of science in America. Now, why is this a problem? Everything that has happened in American exceptionalism. So an example is America, the average American has twice the income now as a European. Good job. Why? We're more innovative. What are we innovative in? Science and technology generated business opportunities. If you think that this sounds like me, a Democrat, let me remind you that fracking was hugely successful in America, made us independent of oil and gas, made us the largest exporter, right? Good job. Followed the same path, right? Innovation in the universities, and then entrepreneurship, and then government support over 30 years. We have plenty of examples of this. Another example of current damage. Universities are so scared because the administration appears to be withholding hundreds of millions of dollars from them. What does a university do in the first thing? They put in a hiring freeze, okay? So you have a graduate student who wants to serve in university, they're graduating. The industry will offer them a salary of $2 to $3 million a year, and they're foolish enough to turn that down. They want to serve the university, they want to teach, they want to build it. They call up the university and they say, we can't interview you. So they go to industry. Good for industry, they stay in America, but we lose that for our seed corn. Current faculty members, because they can't get the research money, are unlikely to be able to get to tenure in the way that they have to, and those people's careers will be destroyed. Now, this madness will eventually end because it's too stupid not to fix.
But it's going to be too late, won't it?
But there's damage occurring already, and I want everyone to understand it's real damage, right? We're up against China that is pouring $1 trillion into this, and we're screwing around with funding the core people to invent our future. Anyway, I can go on.
I've heard some people say U.S. science is being gutted. Would you go that far?
Well, that's the language that the university professors say. If you look at bio, which is the subject today, pretty much all the bio research is burdened at about a 65 to 85% overhead rate. And this is why the NIH cuts are so profound. So to go from 85% to 15%, you have to cut your budget in half. Now, you can call that gutting, you can call it cutting in half, but it's people's lives, it's programs, they're all getting stopped.
Are you doing anything about this? Are you having conversations?
Well, there's a bunch of philanthropists who are trying to figure out a way to spend more money, which is always a good thing.
I can help you, by the way.
The problem is the numbers are too large. Private philanthropy generates some number of hundreds and hundreds of millions of dollars a year. You can't make up the billions and billions that the government provides. Remember the deal that was done before virtually all of us were born. That deal was the government would provide basic support for research, the universities would produce it, the venture capitalists would spend an awful lot of time with these people and they would create companies. The government would then provide necessary market making or whatever to do this, and it has produced these industrial champions. That is the American way. Don't change it, please.
We are going to take your questions. We are going to take some audience questions in just a minute, so put on your thinking caps. I'm wondering about private investment. We've heard a lot about it here today. And what are your thoughts on the current economic turmoil and what that is doing to the mood to invest in AI and biotechnology?
I think everyone in the room understands that businesses need predictability. And so any system where the rules change every week is pessimal, right? Because people are making very, very long-term decisions. I'll give you an example. Most people think that we need 10, 20 gigawatts of electricity, which translates to data centers. Those data centers, typical chip is 2 kilowatts, so you can do the math. These end up being, I don't know, $50 billion, $100 billion decisions. They play out over, takes a couple years to build the data centers. You have to then get in queue to get the GB300 from NVIDIA and so forth. The economic uncertainty slows that. It happens, but it happens slower and with greater latency. All of these slow down the vision that I just outlined. Now, why is this important? I'll give you one more example. And this is what I'm really worried about. Let's imagine, so we'll use, you're the good person, you're the good lady and I'm the bad guy.
I like that.
Okay, and the good lady, the United States in this case, is ahead, and you've done everything right. I'm the bad guy, China or whatever, and I'm 6 months, 12 months behind. As you get closer to superintelligence, right, I get more and more worried unless I'm going to be there the same as you. And you sit there and you go, what's he complaining about? You know, it took 4 years for the atomic bomb to be recreated in the Soviet Union. During that 4 years, we had a monopoly, but it was fairly quickly eliminated. These are network effect businesses. And so network effect businesses have the property that the leader tends to get 90% share. So in the scenario where you, the good lady, are doing this, of course we would all applaud you as Americans, you're likely to get 90% share or more of intelligence in the world. Okay? That would be terrible for me.
Right.
What would I do?
Try to undermine me.
Okay, let me tell you how I would start, just to give you a heads up. The first thing I would do is to try to steal your intellectual property and the people.
Check.
Okay? And you're such a good lady that you've managed to prevent me from doing that. The next thing I'm going to do is use my AI, which is almost as good as yours, to go into your AI, these are called adversarial attacks, and modify your system.
Check.
And you go, no way, because we have such great cryptologists, we're so far ahead of you, that 6 months we anticipated this. What's my next move? I bomb your data center. But think about it. We're having this whole debate in our nation about what to do about Iran's nuclear program, and I'm not an expert in that. But these are the kind of conversations that happen here in DC. So when we get to the point where China is N months ahead, are we willing to bomb their data centers? My favorite example here is I've been working on this. I was talking to somebody who said, the answer is obvious. I said, what? The good lady and the bad guy, we agree to a treaty where each of us puts dynamite on each other's electricity supply. You get to blow up my electricity if you get mad, and I get to blow up your electricity if I get, you get the idea. Now,
some would say we've already done, that's already happened.
Well, kinetic attack on people's data centers is probably an act of war.
Yeah.
So this is the kind of thinking that people are, and obviously that proposal is rejected. I'm using it as an example, it's not going to happen. But this is an example of where the proliferation issues, and technically this is called the eye of the needle problem. You have to get through this eye of the needle without killing yourself and killing everybody else to get to this promised land of AI.
Speaking of relationships with other countries, in this report and in other conversations I've had, people have talked a lot about the need in the technology space to collaborate with our allies and with our friends. Let me bring it back to the current moment one more time and ask you, are we going to see that kind of cooperation taking place?
Well, we need to. If you look at how you compete with China, which seems to be how we frame things now in Washington, we're only going to succeed if we have partners. The best partners are Canada, the European Union, Israel, places like that, Korea, Japan, so forth. If you can't articulate that, then you don't understand these are scale businesses. Right, so I'll give an example. Japan has recently come up with a new EUV technology, which I don't fully understand. It's new physics, to compete with the ASML machines that are currently being used in Taiwan. This is good. That competition, historically a monopoly, will give us more choices as to how we can have the supply of chips that we need for our nation and national security. Right? Thank God for the Japanese. Who thought? You see my point. We need to keep these people tight because we work better together.
But we're not doing that right now.
Well, that's a mistake.
I'd love to take some questions. There are some folks with microphones who might be able to identify themselves for me. You have the man right here. Do I see some hands out there of questions? Here's one right at the front.
Right at the front.
Have we got a mic? Oh, bless you.
The mics are showing up.
Right here.
AI will imagine your question and ask it for you.
That's right.
Hello. Greetings, Dr. Schmidt. Mini background, I'm a recent PhD in biomedical engineering. Very excited, I've been following you. Just a very quick question. Do you think there's implications for ASI via drug discovery for like curing cancer and or personalized medicine? Just something very quick.
Yes, because under the assumptions of superintelligence, these are systems that see things that we don't see. And so the assumption is that ASI, for example, could understand biological and cellular mechanisms that you are an expert in and I'm not, at a level that humans will not. So that's why this is such a big deal. We've always assumed that humans would know, there would be at least one human, right, we call these people polymaths, that would understand these things. We're going to end up in a world maybe 10 years from now where we won't actually understand why, but you as our scientist will say, I use it every day. When I was at college, I was studying quantum physics, and my friend who was a graduate student who was much better than I, and I said, is this stuff actually true? It's like too weird to be true. And he said, yes, we use it every day. And I imagine in 10 years, some young student will come up to you and say, is this stuff true? And you'll say, frankly, I use it every day. No human understands it. What an interesting situation for you as now a senior researcher 10 years from now to have to deal with.
Do we have another question out there? At the same table, we have one here.
Yes, ma'am.
Microphone.
We're discriminating in favor of the front row.
Well, that's
yes,
who I
ma'am.
can see.
Yes.
But we need a mic.
There's a mic over, well, the mics are in random places. There's a mic over there.
The mics were in people's hands that were running them around, I thought.
He's right over there.
Well, thank you very much.
Okay.
Great conversation. I had a question about parity, even within the U.S. Imagine my young researcher where I'm a small company. I don't get to compete in terms of having the resources or GPU, DevOps, or all of the things that go to help me manage my data, organize my code, and get the right computer orchestration. And how do we create the resource so that it's not just top companies, top things that can run away? Because that also creates a issue in research because I won't be able to validate someone else's because they have more resources.
Exactly right. There's a proposal called NAIR, National AI Research, which was proposed by a group at Stanford, adopted among the university system. We have endorsed it a great deal to try to get enough hardware. If you look at the math of what these companies are proposing, universities will never have that kind of resources. They never did in physics, they never did in chemistry, they're not going to have it in AI. There's good news, which is at least the open source models, and which are essentially pre-trained, will be available to them, and we'll have robust such things. And that we'll be able to take a powerfully trained model and then adapt it to your specific area. And I think that's the best solution that we can come up with.
Where's that mic now?
Is it?
Do we have it? Okay, just speak up because I can't see you.
Can I ask a question about the confluence with the other exponential technologies? So we've been talking about AI and bio, but there's fusion, there's quantum. What do you see that coming together of the triumvirate looking like? And how do we think about maintaining competitiveness in all three so that we advance all those at the same pace?
I'd love we can. I don't think we're going to be able to keep at the same pace. To some degree, because the AI revolution is essentially math, and it's governed by essentially 3 scaling laws. There's a very good paper by Dario called the Machines of Loving Grace. The first scaling law is the law that you see with ChatGPT and others, where if you just add more hardware and more data and more time, it just gets smarter and smarter. The second one involves reinforcement learning and planning, the examples that I used. And the third involves something called test time training, where the system is learning as it's doing. The latter 2 are just at their infancy. So it looks like in core AI, we are riding these exponential curves and we've got more to ride. No one yet, I've asked this many times, no one yet has seen those limits. We thought there might be a limit when we ran out of stuff to train on. We've essentially sucked all human knowledge, as written down anyway, into these models with all sorts of implications. But there's plenty of data that we can generate to keep powering those things. So it looks like those exponentials are going to go quite a bit faster than the others. So if you look at fusion, for example, AI is necessary for all fusion designs and all fusion management, especially the plasma, but the core science is not running on an exponential. In quantum, it's the same argument. So we'll get there, but I think AI is going to lead first. The reason I chose programming and math as opposed to the hard sciences, or I guess they're hard, but the other hard sciences, is that programming and math are scale-free. In other words, there's no hardware constraint. It's just if you have enough electricity, you can just do more math programs. You don't need more biology and more labs and more whatever. That's why I think it'll burst there first and then diffuse into the other fields.
I'm sure there's another question out there, Mr. Microphone. I'm going to let you pick because I can't see anything.
How about over
Do we
here?
have someone with a mic? Here we go.
Hi, Sidney Friedberg from Breaking Defense, and a longtime follower of your work with Bob Work, actually. Let me ask, as a longtime science covering reporter and science fiction fan, but also an AI skeptic, how confident are you about this superintelligence thing? I mean, we've had the ChatGPT revolution for a few years now, and it seems to produce often super stupidity. Instead, or at least if you turn the temperature way down and feed it with RAG and tell it only to use trusted sources and pull the citations and to make citations to real things, not imaginary things, you will get the lowest common denominator of what you put in the database. That, the exact opposite of creativity and superintelligence and the ability to discover anything new. The LLMs seem to be, the great distiller of sort of thin gruel from the combined knowledge of human civilization, which is useful in certain applications, like for the government here in DC, we produce reams of paper no one ever wants to read, so we can make the AI read them and summarize them for us. But
do you have a question for us?
How is that heading towards super intelligence as opposed to super mediocrity?
My favorite current example is I'm on the board of a hospital, and the insurers send letters that are generated by a computer to reject treatment. So this particular hospital uses the equivalent of ChatGPT to generate appeal letters. So you have a computer writing a letter and this is how we run our medical systems. So to go back to the stupidity point, the fact that AI is good at something doesn't mean the process that it's embedded in makes any sense at all. I don't agree with some of the things you said, in particular that the algorithms are so much better in terms of hallucinations and so forth in the last year, and they're getting much stronger. But the real arrival is reinforcement learning, which allows you to do path-dependent reasoning. We don't know where that limit is. Let me give you an example of a question that we don't know, which I think will help answer your question. What is the limit of knowledge? Okay? So I'm not a brilliant person. I've just learned a whole bunch of stuff. And so I run out of ideas and then I don't know what to do. The truly brilliant person will look at something. This is how science works, this is how biology works. The greatest inventors, they see a pattern in one area, and then they're able to apply it in a completely different area. So I'll give you an example. Let's say that there's a prime number component in one area, and they happen to notice that primes are present in the other area, and they can use the same tools. I'm oversimplifying. That's genius. We don't today have the algorithms to produce that, and people are working on it. So the answer to your question is I'm betting that we can solve that problem. If we can't, then we'll just be stuck with a computer in your pocket that's as smart as the smartest human ever lived, which is big enough.
Yeah, pretty good. Microphone.
Over there, behind you.
Jonathan Jacobs, ATCC. There's been a lot of discussion today about data and its importance for the advancement of biotech, the confluence of AI. And earlier, you were talking about what adversarial risks there were, in the sense that you went all the way through to reciprocally putting dynamite in each other's data centers, right? So I'm wondering if you can comment a bit on the importance of data authenticity and provenance. One of the concerns that I have is the vast majority of public data that's being used to train these models is originating from databases which anyone in the world can contribute content to. And there's often not the provenance behind how that data was generated. And that seems like a risk.
I think the provenance question that you're asking is really fundamental. The AI systems can take noisy or bad data and normalize it. But if the data has been deliberately altered, which is, I think, a way of thinking about it, that's going to be a new kind of national security risk. If you look in biology, the core problem in biology is we don't have enough data. We just don't have enough data. There's so many cellular processes, and so you'll go to a lab, which again, we're busy defunding for some reason, and they're generating that data. That data should be for public use, reproducible, peer-reviewed, and so forth and so on. There's an interesting development. Anthropic brought out a protocol called the Model Context Protocol. And in the last 3 months, it's been adopted by every company. It was done in open source. And it basically, if you have data, it allows the model to just structure the data in any way you want. So you can literally say to the thing that talks to MCP, to the actual data, you can start asking it questions. This has huge implications because it means you don't have to build all the data connectors. You can just have the raw data, and then the model is smart enough to navigate the raw data to answer your very sophisticated question. So that's a big improvement and a big deal that just happened in the last few months.
I think we have time for one more. This table in the front is very anxious to participate. Microphone.
Yeah. Question back here.
Okay.
Yeah, thanks for the
Sorry.
great conversation so far.
I feel like
my name's Leonard
Sacagawea up
Justin.
here.
I'm a PhD student at MIT. I was wondering if you could just discuss a bit more some of the risks you see coming, specifically with respect to biology, and how we should go about mitigating those. What's the role of the AI developers? What's the role of government? How can we move forward on that?
So you're going to know a lot more about this area than I, but speaking as an amateur in your field, the two current risks from these models are cyber and bio risks. The cyber ones are easy to understand. The system can generate cyber attacks, and in theory can generate zero-day cyber attacks that we can't see, and it can unleash them. And furthermore, it can do it at scale. In biology, you get some evil, the equivalent of Osama bin Laden. They would start with an open source model. Now, these open source models have been restricted using a testing process. They're called cards, and they test it out, and they delete that information from the model. It turns out it's relatively easy to reverse essentially those security modes around the model. And that's a danger. So now you've got a model that can generate bad pathogens. Then the second thing you have to do is you have to find things to build them. Our collective assessment at the moment is that that's a nation-state risk, not an individual terrorist risk, although we could be wrong. But there's plenty of examples, and the report talks about some of the Chinese examples, where in theory, if they wanted to, they could not only manufacture bad things, but design them, but also manufacture them. The good news, and the reason we're all alive today, is that the bio stuff is hard to manufacture and distribute and to make deadly and spread and so forth and so on. There's lots of evidence, for example, that you can take a bad bio right now and modify it just enough that the testing regimes and the sort of surveillance regimes it bypasses, and that's another threat. So that's what I worry about. But I think at the moment, our consensus is we're right below the threshold where this is an issue. And the consensus in my side of the industry is that one more or two more turns of the crank, these issues will be, and by then you'll be graduated and you can sort of help solve these problems. A crank is turned every 18 months or so. This is about 3 years.
But theoretically, couldn't AI and biotechnology help you come up with a countermeasure?
I had thought so, and that was the argument I made until I do a lot of national security work. And there's a term called offense dominant. And an offense dominant is a situation in a military context where the attack cannot be countered at the same level as the attack. In other words, the damage is done. And most biologists who've worked in this believe that while the model can be trained to counter this, the damage from the offense part is far greater than the ability to defend it, which is why we're so worried about it.
I hate to end this on such a down note, so I'm going to ask you for a positive outlook. Look down the road and tell me how you think AI and biotechnology are actually going to change people's lives.
Well, let's thank the financial system, the hardware people, and so forth for allowing us to build immense data centers with billions and billions of dollars of hardware with no clear revenue purpose. So thank you very much. What will happen as all of that stuff gets deployed and it's coming out is it's going to be used by incredibly clever people to solve some of these problems. And I'm not talking about the policy problems, I'm talking about the actual underlying problems. You're going to end up with these huge databases of information we don't need. We don't have now, excuse me, we do need. And an example would be that we still cannot do a digital model of a cell. Seems like a kind of a basic thing. I was talking to my biology friends. It's like, what's wrong with you? You've been studying cells for like 5,000 years. The actual number is like 150. What's wrong with you? And the answer is it's really hard. We're pretty close to being able to do that. That unlocks huge medical science, huge drug possibilities. The language that cells talk to each other. I happen to be the chairman of the Broad Institute. This is a big project at the Broad. We're just on the cusp of that. When you talk to the scientists, they're using AI to generate it. The scientists are in charge and AI is helping them, which is the correct order. Thank you.